Often when students are asked to manipulate fractions, for example with addition and subtraction, they'll be asked to show their answers in lowest terms, or simplified, or reduced. All of those terms mean the same thing: simplify, reduce, lowest terms. They all mean to put a fraction into its smallest form so that the only common factors that the denominator and the numerator have in common is 1. I'm going to show you what that means. So basically when we simplify, reduce, or put a fraction into lowest terms, we're making it smaller. The main way to do that is to go back to finding the greatest common factor. So if you review prior videos, the way that we do that is we write the numerator and the denominator like this. And factors are numbers that divide evenly into the given numbers. And the way that I train my students to think about that is actually using multiplication tables. So, 28. We start with the counting number 1. 1 times what gives us 28? And the answer would be 1 times 28. So we put the 1 here and the 28 here. Then you go to the next counting number. Does 2 times any number equal 28? The answer is yes. It would be 2 times 14. Assume that the student couldn't remember that. What they could do is they could go to a piece of scratch paper and try the division. And we get 2 goes into 2 one time. 1 times 2 is 2. Subtract. Bring down the 8. 2 divides into 8 4 times. 4 times 2 is 8. There is no remainder, so yes, 2 does divide evenly into 28 14 times. So it would be 2 times 14 equals 28. We put the 2 here and the 14 here. The student goes to the next counting number, 3. Does 3 times any number equal 28? And the answer would be no. Does 4 times any number equal 28? The answer would be yes. 4, we put that here, times 7. Then we go to the next counting number. Does 5 times any number equal 28? And the answer would be no. Does 6 times any number equal 28? The answer would be no. Does 7 times any number equal 28? The answer would be yes, but we already have 7 times 4 written. When that happens, we know that we're done factoring 28. So there are the factors for 28. Now we do the same process for 42. 1 times what number gives us 42? It would be 42, so we write that over here. Does 2 times a number equal 42? Again, the students might think that's true because they recognize that this is an even number, but they may not know what to multiply by. If they don't know what to multiply by, they can go ahead and do the division on a separate piece of paper. 2 divides into 4 2 times. 2 times 2 is 4. Bring down the 2. 2 divides into 2 one time. 1 times 2 is 2. Subtract. No remainder. So again, 2 times 21 equals 42. So we put the 2 here and the 21 here. Does 3 times any number equal 42? The answer is yes. The students may not know that right off the bat, but they can try it using division. 3 divide into 42. When you do the division, the student will see that yes, we can create 42 with 3 times 14. So we put the 3 here and the 14 here. Continue through the counting numbers. 4 would be the next number. Does 4 times any number equal 42? The answer would be no. Again, if the student wasn't sure, they could do the division. They would see that there's a remainder. Does 5 times any number equal 42? The answer is no. Does 6 times any number equal 42? The answer is yes. 6 times 7. So we write the 6 and we write the 7. And we would go to the next counting number, which is 7. Does 7 times any number equal 42? The answer would be yes, it's 6. But we already have those 2 factors there, so we're done. The next thing that you do is you look for the greatest number, the greatest factor that these 2 given numbers have in common. When you look at the list, the greatest common factor here is 14. We use this information to reduce this fraction, to simplify this fraction. You take the greatest common factor and you divide the numerator and the denominator by that number. So, 14 divides into 28. The students can return to their work here to figure it out, that it was, here's 1 times 28, 2 times 14. 14 divides into 28 2 times. And then we have 14 divided into 42. Again, the students can use their list here to figure it out. 1 times 42, 2 times 21, 3 times 14. So 14 divides into 42 3 times. Now, as you can see, if you examine this fraction, the only factor that can divide into 2 and 3 is 1. This fraction is reduced completely. The only number that I could divide both of these by at this point is 1. Their greatest common factor would be 1. When you get to that point, you have reduced the fraction. So 28 over 42 reduces to 2/3. Now this is a long process, and it's very effective. But if students don't wish to use this, there are other ways to reduce fractions, which I'm going to show you now. I will use the same fraction so that you can see that you end up with the same answer. So, for example, if the students were given 28 over 42, and they were told to reduce or simplify this fraction or to put this fraction into its lowest terms, what I told the students is that anytime you reduce or make something smaller, that's a signal for either subtraction or division, making something smaller. And with fractions, we're talking about division. And so the students know that they need to divide the numerator and the denominator by the same number because we have to keep the fractions equivalent. So they're looking for something that they can divide the numerator and the denominator by. A lot of times students will look at this, it's a large number, and so what they will see is that they are both even. And so they can start with 2. They may need to write down the division on scratch paper. 2 divides into 28 once. Bring down the 8. And they go, oh, it's 14. And so they write 14. And then they may need to write it down again for the next number. There's nothing wrong with that. You divide 2 into 42. When the student completes the long division, they see that the answer here is 21. And so we look at the next fraction the next equivalent fraction that we've created, and the student needs to ask themselves, can I still reduce further? The answer would be yes here. And so they have to think about a factor that can divide into 14 and 21. And eventually they may have to try a few numbers, but eventually the students will realize that the factor that they need to use is 7. And so again, they will divide the numerator and the denominator by the same number. It must be the same number. All of these fractions need to remain equivalent. And so 7 divides into 14 2 times, and 7 divides into 21 3 times. And then they need to examine this fraction as well. And they need to ask themselves, have I reduced this fraction completely? And the way that they know that they have reduced the fraction as far as it will go is the only number that I could divide into both of these numbers, the numerator and the denominator, the only number that I could divide into both is 1. And when that happens, your fraction is reduced into lowest terms. So you can see that we got the same answer. It's up to the students which method they prefer. And this way is perfectly acceptable. The students just need to be able to realize if they get to a certain point, they need to realize if they need to continue to reduce further. And that's what they need to look for. And that's what we did here. So I hope that helps with reducing fractions.